Hey there, how's it going? So as you can see on my screen, I have Qwen3.8 Unsloth page here. Now I wanted to make this video pretty quickly because we have just so many models that are dropping that I don't even have time to download all of them. We just had DeepSeek V4 with the Flash and the Pro model release. We had Qwen3.8 2.4 trillion parameter model drop, and we also are going to have the Qwen 3.8 27B coming out shortly today, as well as the GLM 5.3. So today I'm just going to be covering Qwen 3.8 2.4 trillion running locally on hardware. Again, this is just local, and of course API quality is going to be different because that is the max model, and this is apparently a different model from the one that is hosted. So let us get right into it. The first thing I want to note is that I am running the Unsloth version of this, the IQ1S version, which is 508 gigabytes in size. It does fit on the Mac just barely at 508 out of 512. But basically, you have to close everything that you're doing to run it. I am loading it right now, as you can see, but you're probably going to have a hard time recording at the same time. Now, on the screen here, you do have an example where I am running this. I played around a bit with the inference settings here, but honestly, I don't think that is required too much. This model is very smart, even at 1-bit quantization. Now, when I say 1-bit quantization, I do have to be careful because it is a bit different than just cutting the experts to 1-bit. There's basically this code books which is a complicated way of compressing things and then uncompressing things based on patterns that they recognize. There is basically 11 bits, and then it has to go to a code book and kind of uncompress it if that is the picture that I'm trying to paint. It's a bit different than just cutting the expert to 4-bit. It's more of like a dynamic way of compressing things. Now, I do want to just come back here to this page now that the model is starting to load here. As you can see, it actually wasn't able to load properly into my VRAM because I am recording. And at the top right hand corner, you'll see that Unsloth is basically fluctuating the VRAM back and forth between memory and cached files. This means that my context length is just too high for the current memory that I'm using, which is basically the video, as well as running this on all the VRAM that I have. The other thing I do want to mention is this will happen to you if you do a restart and you don't increase the memory footprint that the Mac can use, because I believe it can only use 75% unless you set it otherwise. So let me just do that quickly for you. All right, so I unloaded the model, and every time you restart your computer, you kind of have to open the terminal and do this command. And basically what this command means is we are increasing the limit for the GPU to be able to use the full 512 gigabytes of VRAM rather than just limiting it to like 460 or something. So if you're trying to load a massive model that's larger than 460 gigabytes in size, you want to do this every single time. Now we're just going to enter a password, and now it's basically telling us that we have a large limit there. Okay, the second thing that we want to do when we are basically trying to load a massive model such as Qwen3.8. Qwen3.8 here. Just click it and then go to configure. Now we're gonna configure this to 32.765 for now, and that's because I am recording at the same time. And on the Mac, you are able to use 65K with F16 or 65K with, 131K with Q8 if you close down everything. The other thing I also do is add MTP. Because this model does have MTP, I don't really care for Ngram that much, actually. Okay, so now that it's going to be loading, it should fit into our VRAM and it should have a stable 509, 508 gigabytes of memory utilization. Now, this specific model, as you can see, does run at about 9.6 tokens per second, up to about 10 tokens per second when you use MTP as well. The other thing I do want to mention about this model is that it does have reasoning modes, but you cannot set it to none. So low, medium, and extra high. Also, it has preserved thinking. Now, the difference between low and extra high thinking is massive. And this is going to be your main vector of controlling how much reasoning you will let this model do. And I would technically try to use medium or low. Extra high probably won't even fit into the amount of context length we have. Now, I did try medium once and it went to like 96K tokens on a complicated test, which I will show you in a bit. So extra high will use as much as possible. Low is very good for short generations if you just need to the point straight answers. And as you can see, it is loaded now in our memory. Now I can show you that over here. So this is a generation that I did previously, and basically it's just saying hi. You can see it only thought for 4 seconds. I did a 9.7 tokens per second output. Then I asked it for a Pelican riding a bike, and normally this would have been completely horrible at Q1, but luckily it did produce this Pelican riding a bike. Now, the other thing I just want to note with this Pelican riding a bike is that it is very simple, and that's because we did have it on low reasoning mode. It basically thought for about 22 seconds and then just straight out output the Pelican. So this is very good because other models would have thought for quite a while just to get this kind of quality. The other thing I do want to mention is that the whole bike is basically here. We don't have much quantization damage, and the only thing is like the leg is on the other side of the body, but this is, relatively normal for the amount of thinking that it did. So this is actually surprisingly a very good output, considering that I also want to go ahead and let you guys know that I did a bunch of other SVGs here. So I was playing around with some of the outputs, and this is mostly on medium reasoning. So this SVG of a PS4 controller is on medium reasoning. As you can see, it thought a lot. And I do want to dive a bit into the thinking process as well, because this is a bit new in these models. As you can see, it is doing a bit of short form thinking rather than full out sentences, which I do appreciate. Yeah, as you can see, it is trying to line up symmetry, etc. It goes through it. It will do inside of the thinking reasoning after. Wow, my camera died for a second. Okay, so getting back to here, as you can see, it does code blocks here, and then it tries to double check and correct itself, which is normal for models, but it does a pretty good job of just laying out things and then going from there. Now, in the end, I think for quite a long time, and then output the full PS4 controller here. It obviously does not look exactly like a PS4 controller. What we're really looking for is that the layout is correct. You will have in a lot of these models where the speaker grill is like outside the body, and some of these buttons are outside the body. So it is good that everything is inside this body. Now, again, this is roughly 7.8 tokens per second, and it printed 28,000 tokens. So it is very, very large in its thinking traces, and this was set to, I believe, medium at this time. Let us go ahead and review some other outputs. Now, here I asked it to create a flight simulator, and unfortunately the first time around I ran out of tokens. It went to 32k, so I had to actually paste it back in for it to go ahead and review that. In Unsloth Studio also, you should note that there are passes that it will do to verify that everything works out. Some of these passes are basically trying to figure out like what is going wrong in the first couple of seconds of the game, etc. So it'll run it, it'll execute, and then it will go ahead and try to, correct it. So in this case, it was trying to track the camera, and if the gravity was working out. Now, this game output is pretty complex in terms of what it was doing. It was trying to do like a gravity simulation. So it was kind of, instead of doing just like a vector-based flight simulation where, wherever the nose points, that's where the plane goes, it was trying to do like gravity acceleration, and based on the gravity and acceleration, the plane would, have lift, etc. So it was calculating all of that in the file there, so it was having a bit of trouble leveling all those out. But it did eventually fix it and output the code for me after a long period of time. You can see here we were at 62,000 tokens used at about medium resetting settings. And it did give us a final output. Let me just find the file. All right, so I found the file. This is SkyDrift, and we are comparing this because this is like a 2.4 trillion parameter model. We want to make sure that everything is good. As you can see, the layout is pretty good here. We got pitch, pitch down, bank left, bank right, yaw, throttle, sound, and camera view. We're going to go ahead, and as you can see, we do have a pretty nice way of turning. I am pressing D right now, which is for right, and it is turning right. You can see though on the back here, we do have a bit of a glitch where the rear rudder, aileron is facing the wrong way. But the overall feel of it is very nice. The plane, as you can see, is dropping down. So we do want to speed up a bit to get a bit more lift. And if I were to throttle down, how do I throttle down? We also have a different view here, which is great. Now we don't have many textures, especially on the mountains and the grass here. This is all procedurally generated noise maps. So basically all of these will continue to go in and appear continuously in various different levels. Max speed right now looks like 197, and we are heading southeast. We also have a sun up there. We do have a sun up there. We have really nice clouds, which are like kind of volumetric foggy, not necessarily just like a 1D layer, which is what normally happens. let's see what else. We do have a bit of grass at the bottom, which is kind of highlighter green. Unfortunately, I'm going to turn the sound off. What else do I want to notice? I do want to note that it did a good job with the actual airplane. And yeah, it is one of the better generations. Even if there aren't many textures here, this is quite good. In the second pass, of course, you can just ask it, add textures, add like volumetric water, etc., and it will probably do a really good job. I do like just the feeling of the plane, of how it's flying. Like the camera kind of does a pan here. You can see the side of the airplane. This is very nice. And you can see there are shadows and light hitting the airplane as well. And you can see the lighting changes here. So all of this is very nice. I do want to note, when we go straight up, our speed is climbing. I'm not pressing the accelerator. So this might be a bit of a bug. It should be stalling if we go straight up, which yeah, that probably shouldn't be happening, but otherwise I feel like this is a very good generation, considering this is a 1-bit quantization. Now let me just see if I can stall this plane. Okay, so we basically turned off the propeller here, and as you can see, we do have gravity. We're just gonna start falling here. We're basically stalling, and you can see our velocity line behind us is kind of going down, and we're basically gliding at this point. We don't have lift. Our propeller is stopped, and we're basically gliding down. If we pitch up, we are increasing in speed, and if we pitch down, pitch up, we're not really increasing there. But again, I can start up the throttle, and that will give us lift, and now we can start flying up. Okay, so overall this is really good generation. I'm gonna go ahead and close that. Now let us move on to some of the other things at medium reasoning. So this is a demonstration of a panda sitting, having picnic in Japan, make it beautiful. It did quite a lot of generation here. The note I do want to let you guys know is that it thought through that it would have been simpler to use a Python script here. Open this up. Now this is the panda having a picnic in Japan. You can see that it did add a bunch of these butterflies. There are nice trees, and this is all generated with math. So all of these are basic math, circles and flowers, butterflies. We do want to note that there is extra detail here, such as teapot with the steam. And it has a picnic basket, and it has a onigiri here. There's a torii gate, and it did a good job with lining up this top of the mountain, making sure it doesn't go off the mountain. So honestly, this is a very good generation, especially for this 1-bit quantization. This was medium reasoning. So this was medium reasoning of a capybara, and again it used some of the Python to add noise, such as the snow here and some of the noise on the yuzu. And basically this is a very good generation of a capybara. So this is like a very good, especially everything is in place. There are no errors at 1-bit quantization. Now I do want to show you again a comparison between this and the low reasoning effort, because as you remember in the beginning we had a Pelican, and that Pelican wasn't as beautiful as these generations, and because at that point I set low reasoning effort. Now I did it again with the same capybara prompt here, and you'll see that we do have an output here. I'm just going to go ahead and copy and paste this. Now you are going to see that there is a difference between the quality of the low reasoning effort and the medium reasoning effort here. But there are also a very large difference in how long it thinks. The thing to note about the low reasoning effort is, I guess it put things in the right places where, you know, there are mountains and there's a snow peak and stuff. It's at the top. But again, it didn't go all the way and try to make it as detailed as it could with the medium effort reasoning. Now, this just means that there is a very big difference between low and medium effort, and extra high effort unfortunately would take like a lot of time and a lot of tokens, which I don't know I have the patience for. So mostly I would be using low and medium. Low maybe to iterate, get a plan, and then medium to, you know, just get it ready. And extra high, I don't know exactly if I would be using it. So there you go, guys. That is Qwen3.8 at 1-bit quantization. Let me know what you think. Again, it is a 58 here on the artificial analysis scale, only just behind Fable, GPT 5.6 Soul, Graph of 4.6, and Kimi K3 here. And the Qwen 3.8 27 billion parameter model is coming out later today as well. So I'm excited about that. I just wanted to show you guys and share that a 1-bit quantization of the 2.4 trillion parameter model does work locally at about 10 tokens per second. Prompt processing is at 50, and that is just, you know, amazing. Now go ahead and like, subscribe, leave a comment down below. Tell me which model you are going to be using on your local computer.